So we are working on multiplying and dividing radicals today, which is very similar to our simplifying radicals, only you got one step to do first, and then you're going to do your simplify like we were doing before. So a couple of things. The radicand do not have to be equal when multiplying or dividing, and in case you forgot, right down here your radicand is that number that is underneath the radical sign. So those do not have to be the same when you're multiplying and dividing. However, the index do have to be equal when multiplying or dividing. And again, your index, that is your number out in front of your radical sign. It tells you whether you're taking the square root, cube root, fourth root, fifth root. It just tells you which root it is that you're looking for. So the index has to be the same. Radicand does not have to be the same. So our steps in order to multiply or divide is to check to make sure that the indexes are equal. If they are not equal, then there's nothing further you can do. The original problem would be its final answer. You'll multiply or divide the coefficient. Which, as you can see by my picture up front, those are the numbers in front of the radical sign. So you would actually multiply or divide those if you can. I always say if you can, because you can't always multiply, or you can't always divide them. Next, multiply or divide the radicands. Again, those are the numbers underneath. And then you simplify your results. So you multiply the numbers in front of the radical, multiply the numbers underneath the radical, and then simplify. So my little box, my example here, our two coefficients would be the letters x and y. So we would multiply those together and we would get xy. Underneath the radical we have an a and a b, so we would actually multiply those together and we would get ab. So xy radical ab would be our answer for that one. And then again, you would reduce if you could. So let's take a look at our example. We'll start easy and then we'll slowly work our way to be a little more harder. So we have the square root of 2 times the square root of 6. So first question we have to ask ourselves, do they have the same index? Yes, because they're both square roots. So we can actually multiply these. Our coefficients are both 1s. We don't always write the 1, but that is there in front of that radical, so you would just multiply 1 times 1, and we'd get a 1. For underneath the radical, you'd actually multiply your 2 times your 6. Now, since the 2 and the 6 are underneath the radical, when you multiply them, that answer is also under the radical, so we get radical 12. So we have to ask ourselves, can we simplify radical 12? The answer would be yes. What is our perfect square that goes into 12? 4 times 3. Yeah. So the square root of 4 would be 2. So we get 2 radical 3 as our final answer for that one. All right, let's take a look at number 2. So again, multiply our coefficients. So 3 times 2 gives me a 6. Multiply what's underneath the radical. So we got 3x times 8x. Which would give us 24x squared. So now we're going to simplify our radical. What's our largest perfect square that goes into 24? That would be 4. And then our exponent on our x, that 2, we can divide by 2, so x squared is a perfect square, so that goes with the 4. So that square root of 4x squared would turn into 2x, because square root of 4 is 2. Divide your exponent, you get x to the first. Well, we have to multiply it times that 6 that was out there in front. So our final answer is 12x radical 6. So if we took a look at number 3, we got 2x radical 5 squared. So that means that that thing is there twice. So let's write it out twice. 2x radical 5 times itself, 2x radical 5. And now we're going to follow the same steps. We'll multiply the coefficients. So 2x times 2x would give us 4x squared. 2 times 2 is 4. X times x is x squared. 5 times 5 would give us the square root of 25. Which 25 is a perfect square. What is the square root of 25? 5. So the square root of 25 turns into a 5. It's times that 4x squared that was already out in front. So 20x squared ends up being our final answer for that one. So number 4, same thing. They just wrote it in a different way. You've got one of them in a set of parentheses. When you have something like that, you're still multiplying. So negative 5 times 2 would give us a negative 10 for our coefficients. Multiply the numbers in front. Underneath the radicals, we have 3xy times 6xy. So the 3 times the 6 gives us 18. X times x is x squared. Y times y is y squared. So 18x squared y squared. Is 18 a perfect square? No. So we're going to have to separate this perfect squares and non-perfect squares. What is our perfect square that goes into 18? 9. 9, and then my 2 goes there because 9 times 2 gives me the 18. Are x squared and y squared perfect squares? Yep. So x squared, y squared both go with the 9 because they are both perfect squares. So the square root of 9x squared y squared would be 3xy. I got that radical 2 there still, and again I have to do it times this negative 10 that was already there. I always got to remember to multiply what was out in front. So we get negative 30xy radical 2. So number 5, we switch it up a little bit. Our index turns to a 3. But both of the radicals have an index of 3, so we can actually multiply. So 2 times 4 would give me an 8. And then under the radical, 2 times 4 again would give me another 8. So we have 8 cube root of 8. So is 8 a perfect cube? Yep. Remember, if you look at your perfect cubes list, it's there. Cube root of 8 would be a 2. Times the 8 that was already there, we would get 16 as our final answer for that one. Number 6, again, what are our coefficients? 1. So we don't have to write them. We know 1 times 1 is 1. Cube root of 9 times 6 gives us 54. And then x cubed, because x squared times x to the first, you add your exponents, so we would get x cubed. So now is 54 a perfect cube? No. What is the perfect cube, though, the largest perfect cube that goes into 54? Largest perfect cube that goes into 54, 27. 27, and then over here would be a 2. Our exponent of 3 is divisible by 3, so that's all going to be in the perfect cube one. Remember, we have to be able to divide by that index. So that gives us a 3x, and then the cube root of 2. So multiply what's in front, multiply what's underneath, and then simplify. So on the back, we are going to be dividing, so kind of like our multiplication rules. Divide your two coefficients. So x divided by y. Divide your numbers under the radical, those radicands, so a divided by b. So let's look at number 7. Our coefficients are both 1 again, so 1 divided by 1 is just 1. What's 80 divided by 5? Yeah, so we're doing 80 divided by 5, which gives us 16. So now since the 80 and the 5 are under the radical, the 16 is also still under the radical. I did not use that sign yet, so that's still there. Now we're going to use it. What is the square root of 16? 4. So the final answer would be 4. So let's try number 8. So again, we're going to divide the coefficients, and we're going to divide the numbers under the radical sign. You don't have to write it like that every time, but I like to do it in the notes just so you guys know what we're doing. So 10 divided by 2, yep, gives us a coefficient of 5. 24 divided by 2 gives us a radicand of 12. And so now we need to simplify. What is our perfect square that goes into 12? 4 and 3. 4 goes first because that's our perfect square. What is the square root of 4? 2. And then I got to multiply the 2 times the 5. So 10 radical 3 ends up being our final answer for that one. All right, number 9. Again, our coefficients are 1, so 1 divided by 1 just gives us 1. Let's divide our numbers underneath. 10 divided by 5, 2. X cubed divided by x to the first would be x squared. So when we simplify this, our only perfect square there is the x squared. 2 is not a perfect square. Other than 1, there is no perfect square that goes into 2, so we don't separate it with a 1. So this becomes x radical 2 as our final answer. All right, let's try number 10. 12 divided by 3 gives us a 4. So for underneath the radical, 54 divided by 2 would be 27. Our x's are going to cancel each other because they have the same exponent. So x to the first divided by x to the first is just 1. And then we would get y squared because y cubed divided by y to the first gives us y squared. So now what's our perfect square that goes into 27? 9. So we got 9y squared. And then we got a radical 3. So the square root of 9y squared would be 3y. We'd still have that radical 3 after it because that's not a perfect square, so that stays in the little house. 4 times 3y gives us 12y radical 3. So that's our final answer. All right, we got 2 more, 11 and 12. So let's divide out in front. 30 divided by 6 would give us a 5. 128 divided by 2 should be 64. So again, we're doing cube root this time. So is 64 a perfect cube? It is. What is the cube root of 64? 4. Then we got to multiply it times that 5 that was out in front, so we get 20 as our final answer. So and again, for 12, what is our coefficient in front of our numerator? What number's here? 1. So 1 divided by 2, you could just leave it as the fraction 1/2, or you could turn it into the decimal 0.5. That doesn't matter. But divide those, we get a fraction or decimal. Underneath, there's just a 1 in front of that x, so 32 divided by 1 just gives us a 32. X to the 4th divided by x to the 1st would give us x to the 3rd. So 32x to the 3rd is what we have underneath. So is 32 a perfect cube? Nope. So what is our perfect cube that goes into 32 though? 8. 8 and 4. Our exponent of 3 is divisible by our index of 3, so that's a perfect cube. So the cube root of 8 gives us 2. Cube root of x cubed is x. My 4 stays underneath that radical sign. And we multiply by 1/2. Whether you want to put the 1/2 in parentheses or just put your multiplication dot, it really doesn't matter which one you have. So 1/2 times 2 gives us 1. So we got 1x cube root of 4, or you could just write it as x cube root of 4. Remember, those are the same thing. It doesn't matter whether you put the 1 there or not.